We are going to revisit grouping categorical variables in more detail and see how to get some automated tips on what to group and what not to group. Looking at highest grade attended, remember we previously grouped some of these levels together, but how can we know what levels to group? Domain knowledge of the question provides insight as to what doesn't make sense. We know intuitively there's a natural ordering here in that 1st through 8th grade might be grouped with 9th through 11th grade, or 9th through 11th grade might be grouped with 12th grade, etc. But it's not always clear. For example, should technical school be grouped with 12th grade, or 1 to 3 years of college, or 4 years of college, or professional school? It can become subjective. And then with a predictor like favourite game or activity, the levels include bingo, card games, dice, lottery, and so on. There's no natural ordering in a predictor like that to rely on at all. But even when you know that you could group 1st through 8th grade with 9th through 11th grade, should you? You could eyeball a chart and say, well, these beta values are similar, and this beta value is inside or outside the other one's confidence interval, so therefore they should or shouldn't be grouped. Remember that in any statistical model, the parameters are estimates from the sample data. The beta values are not known. They are only estimated, just like estimating the population mean from the sample mean. And since given uncertainty in that estimate, the confidence interval shows the range of reasonable values of that beta. However, there's a subtle but important problem to keep in mind. The confidence intervals relate to how much confidence we have that that particular beta should be or shouldn't be 0, i.e. whether it should or shouldn't be grouped with the base level, but not how much confidence we can have that they should or shouldn't be grouped with each other. We can eyeball this chart and say that technical school could or should be grouped with 1 to 3 years of college because 0 falls within the technical school confidence interval, whereas because 0 doesn't fall in the graduate or professional school confidence interval, the graduate or professional school should not be grouped with 1 to 3 years of college. But determining whether betas can be grouped with each other requires looking at the covariance between each beta, something that we haven't discussed or looked at yet. But luckily, the factor combinations report has done this for you. Click on the factor combinations report in the drop-down GLM menu. This report provides more ideas around grouping levels within categorical variables. Every paired combination of levels within each categorical predictor is examined. The covariance between the coefficients is used to determine if they are statistically significant and different from each other. Where they aren't significantly different, shown by a cross, they are strong candidates for grouping. Like in the betas screen, a cross means take action, or potentially take action, while a tick means don't take action. As a simple example, gender only has 2 levels, male and female. The gender Z value of 0.307 is less than 1.96, so sex is not significant. These 2 levels, male and female, are not significantly different from each other, so they should be grouped. With only 2 levels in this predictor variable, i.e. male and female, grouping them effectively means removing gender from the model, i.e. the model shouldn't be distinguishing at all between males and females. Now to take highest grade attended as an example, technical school and 1 through 3 years of college are not significantly different from each other, notice the cross, so they could be grouped. Similarly, technical school and graduate school are also not significantly different from each other, so could be grouped. By contrast, graduate school and 1st through 8th grade are significantly different from each other, notice the tick, and therefore these should not be grouped. Tick means take no action, which means don't group them. Working through this, we can see what can and cannot be grouped, but not what should be grouped. There is no single answer. We have situations where A can be grouped with B, and B can be grouped with C, but C can't be grouped with A. The point here is to use this to see what variables can and can't be grouped, building a simple parsimonious model, but still capturing as much information as possible, which might require a bit of trial and error and some domain knowledge about what makes sense to be grouped and what doesn't make sense to group. Then once you're done, check that there aren't any combinations in here that suggest further grouping that you haven't at least considered.